Welcome everyone. Thanks for joining our webinar. My name is Lisa Rosenow and I'm with Evergreen Technology Consulting, or ETC for short. I'll be your host today. This webinar will be the 5th episode of our 7-part series about the 2018 WSEC commercial provisions. We will be focusing on key changes between the 2015 and the 2018 WSEC. The primary topics we'll be covering today are lighting systems and electrical requirements. Before we get started, let's cover a few housekeeping items. We have a lot of people joining this webinar again today, so everyone's audio will be muted to avoid background interference. If you have questions, feel free to post your questions in the Q&A during the presentation. Don't post them in chat, but in Q&A. At the end of the presentation, we'll walk you through a few of your questions. After the webinar, we'll put together a list of the participant questions posted along with responses from our Energy Code technical team. Then we'll send this out as a supporting resource to everyone who's registered. If you experience any technical difficulties, please communicate this to us via chat. We'll do our best to resolve whatever issues you may be experiencing. This webinar is being recorded and will be posted on our new WSEC website. Let's get started. First of all, I'll tell you a little bit about ETC. Our team provides technical support for the commercial provisions of the Washington State Energy Code. We provide on-call technical support through 3 different avenues. You can give us a call via our telephone hotline. That number is 360-539-5300. And if you call that number, you'll get either myself or Dwayne Llewellyn. We man the phones. You can send your email inquiries to com.techsupport@waenergycodes.com, or if you'd like, you can use our new online form via the waenergycodes.com website. We provide classroom and webinar training, and this year we're rolling out all of our training via webinars, and we also administer the new technical support and compliance documentation web tool. Before we get started, we would like to extend our thanks to the Northwest Energy Efficiency Alliance. They support energy efficiency services throughout the Pacific Northwest region. Through their generous support and the support of their utility partners, that we are able to provide technical services and training for the Washington State Energy Code to the design and construction industry. So big thanks to NEA. So here's an overview of our webinar training series for the 2018 WSEC. Our training today is episode 5 of our 7-part series about the 2018 WSEC commercial provisions. On July 29th, we'll provide information about the requirements for additional efficiency package credits in the Commercial Energy Code. And then on August 5th, we'll welcome back Heather Burpee from the Integrated Design Lab and Supriya Goel from Pacific Northwest National Labs as our guest presenters. They'll provide another opportunity to learn about the new TSPR requirement, and will provide step-through instructions on how to use the new TSPR compliance verification tool. Then on August 12th, our technical support expert, Dwayne Llewellyn, will provide information about the service water heating and refrigeration system requirements. All of our past webinars have been posted on the commercial WSEC commercial website, and they are available for on-demand viewing. Before we get started, we would like to share important news about the 2018 WSEC. As many of you are aware, Governor Inslee extended the adoption date of all of the 2018 codes to November 1st, 2020. Then on June 26th, in response to public feedback, the Washington State Building Code Council voted to extend the adoption date further to February 1st, 2021. This extended schedule provides extra time to ramp up on all the new code requirements. Note that they just recently completed a few errata items, which have been incorporated into the second printing. This latest edition of the 2018 WSEC has been posted by the Washington State Building Code Council on their new website, and it is free to download. So a few words about code interpretation. This presentation represents ETC's unofficial interpretation of code intent. Dwayne Llewellyn and I were chatting about this the other day, and he's been involved with the energy code for a total of 9 code cycles, and I've been doing it for 4. So we've been doing this a long time. So we're able to provide a well-informed perspective. However, we do have to inform everyone that who contacts us for energy code support that our technical support team is not an affiliate, nor do we speak for the Washington State Building Code Council. Official interpretations of code intent are made by the State Building Code Council in response to inquiries submitted to the SBCC by jurisdictions. We recommend reviewing the available official opinions that the State Building Code Council has posted on their Answers and Opinions webpage on their new and improved website. So today we are covering 3 primary topics. First, we'll provide an overview of the changes to the lighting power allowances, and we'll share information about the features that have been incorporated into the WSEC commercial website to handle compliance verification for lighting power. We'll also cover a few details about the lighting controls requirements. We'll share information about how controlled receptacles are handled in an alteration project. And we will introduce the new solar readiness provision. To get started, let's talk about key changes in the lighting system provisions. There are several changes in the lighting provisions between the 2015 and the 2018 WSEC. What we'll cover today are details about the changes to the lighting power allowances and the expansion of the occupant sensor requirement to cover more space types. We'll also share information about Luminaire level lighting controls as an alternative to the prescriptive lighting control requirements. Let's start with lighting power. During the code change proposal evaluation process by the State Building Code Council Energy Code Technical Advisory Group, the TAG reviewed 3 different options that had been submitted for the lighting power allowance reduction. Multiple industry representatives and code development experts were involved in this debate. The updates that were eventually selected reflect roughly a 10% reduction in lighting power allowance values. This is not an across-the-board reduction. Each space type was evaluated based on the lighting needs of the space and the types of lighting technologies that are most commonly used. Based on feedback from electrical engineers, contractors, and lighting designers, it was evident that the current LPAs in the 2015 WSEC were in many cases too conservative. The LPA reductions in the 2018 WSEC reflect the growth of efficient lighting technologies that have become prevalent in the industry that provide higher lumens per watt. There are also several changes to the additional lighting power allowances. The general 2% allowance based on ceiling height is no longer available. In the 2015 WSEC, this applied to spaces with ceiling heights greater than 20 feet, and in office and library areas with ceiling heights greater than 9 feet. Now, note that the atrium LPAs that are based on ceiling height, those are unchanged. The additional retail display allowances have been reduced by approximately 25%. And all of the additional allowance information is located in the footnotes for the space-by-space LPA table, and then under the additional interior lighting power section for retail. Additional lighting power allowances in the 2018 WSEC include retail display lighting, art and exhibit lighting. There's a new allowance for lighting over a classroom whiteboard or chalkboard, and for ornamental lighting. Note that ornamental lighting includes chandeliers, wall sconces and lanterns, neon and cold cathode lighting, moving lights, light colored panels, that sort of thing. To qualify, the lights have to be used in a decorative manner that does not serve as display lighting or general lighting. They also must be controlled, all of the additional allowances, they must be controlled independently from general area lighting. So we'll cover all of the additional efficiency credit changes in our next episode. However, here's a sneak peek to explain the changes to the efficiency credits for interior lighting. Note that in the 2018 WSEC, these are referred to as credits and not options. So in a nutshell, this one credit package has been divided into two in the 2018 WSEC, with one credit for set aside for projects where the LPD is 90% or less than the lighting power allowance, and the other is for projects where the LPD is 80% or less than the LPA. Stated differently, there are credits available for projects where the lighting serving a building or space is 10% or 20% lower than the code maximum LPA. These LPA credits may be determined using the building area method or the space-by-space method. Lighting power allowance calculation procedure for the exterior lighting has been simplified. The allowances are no longer referred to as tradable versus untradable or non-tradable. The base site allowance, which is determined based on the designated lighting zone that the project is physically located within, is now only applied to what were formerly referred to as the tradable allowances. Those fixed allowances, those cannot be carried over, meaning any unused wattage from one exterior surface or area from the fixed allowance list cannot be used in other areas. So another way to think about it is that the what were formerly the tradable allowances, they can be utilized in a similar manner as the interior space-by-space method. And the fixed allowances, they're more like the building area allowances, where you can only use them for the particular purpose of that surface, and you can't carry them over into other areas. The existing exterior LPA values, they haven't changed. However, there are a few new exterior surfaces and areas that have been added to the list. There are new allowances for outdoor dining areas, for landscape lighting, for pedestrian and vehicular entrances and exits, and for loading docks. So now let's talk about how the new WSEC Commercial Documentation Web Tool handles the lighting requirements. There are various helpful ancillary features, such as the Energy Code Documents portal, where many of the WSEC official documents can be referenced from one place. We have incorporated various integrated education resources, such as the FAQ tool. So what you can do on this page is pick a topic from a drop-down menu, and what will appear are various questions that we have received through tech support and the interpretations, official and unofficial interpretations that we have developed for that particular topic. We are working on this every day. We have about 100 entries in here now, and we're adding more and more all the time. So we do encourage you to go back to this every once in a while and check out what new information may have been posted. So specifically for lighting, we have developed a lighting power compliance documentation console. This feature supports the building area method and the space-by-space method lighting power allowance calculation. It supports additional lighting power allowances. Those are the ones we talked about just a few moments ago. It applies the interior lighting additional efficiency credit multiplier to LPA calculations to verify compliance with this measure. And it includes various lighting controls prompts. And lastly, we also have a smart lighting requirements list, which replaces the LTG check form. So unlike the Excel LTG check form, which is a generic list of code requirements, the Smart Requirements List feature applies the answers you've provided to various general questions about your project and generates a list of energy code requirements that are specific to your particular project. Any non-applicable requirements, they do not go away, but they're grayed out, so you have a customized list to work from. The main event are the interior and exterior lighting compliance consoles. For interior lighting, this feature consolidates the LTG building area form, the LTG space by space form, and the LTG display lighting form all into one tool. Often a designer will start by checking out to see if their project complies via building area, because this is the simplest approach. Typically, there will only be one or two building area types in a project, so determining the gross interior area square footage requires minimal effort. However, if a project doesn't comply via building area, the designer or contractor may then sharpen their pencils and divide their project at a more granular level using the comprehensive space-by-space type list. We found that in many cases, the space-by-space method generates a more generous allowance than the building area method. So it can be worth the extra work to divide the building up with a lot more detail if your project doesn't meet the building area method. Now, when you were using the Excel forms, if the designer opts to switch from building area to space by space, they have to enter all of their proposed fixture information twice into each of these forms. In the online tool, the designer only enters their proposed lighting fixture information once, and then they can easily switch back and forth between the building area and space by space lighting power allowance checks. So hopefully that'll help folks save some time. In addition, if the designer wishes to check to see if their project meets the interior lighting additional efficiency credit, they can turn it on and off right up here. The lighting console runs a compliance verification check and prompts the user about details that do not comply. Note that for the building area method, each building area type is verified separately for compliance. For the space-by-space method, all of the LPAs are combined and the total proposed lighting power is compared to the total lighting power allowance value. The exterior lighting compliance console, it functions very similarly to the interior console. All of the information entered into the lighting console is captured in an output report. The tool does not check for lighting controls compliance, since this detail is highly variable depending on the scope of the project. However, there are various lighting control prompts and questions integrated into the tool. All responses provided to these questions are captured in the output report. This report is then turned in with the lighting plans to the jurisdiction for a lighting permit submittal. So the 2015 code currently is supported with two different tools. So the Excel workbook forms, those for envelope lighting and mechanical, they're all still available. They're posted on the WSEC website, and they're going to be there for a while. Lots of projects, roll in for permit just before the new code goes into effect, and it can be a pretty long period of time, up to 2 to 3 years. After a code changes happened, where folks still need the 2015 compliance documentation forms. So we'll make those forms available for quite a while. We also have developed the online tool to support the 2015 WSEC. So it has similar scope as the Excel forms with more detail, expanded compliance checks, and lots of new support features as we talked about a moment ago. Then for the 2018 WSEC commercial provisions, the only compliance tool we will have available is the online tool. We will not be replicating the Excel forms for 2018. So we encourage everyone to go check out the new tool, get your feet wet, get the hang of how to use it. If you have any questions at all about how to use the form, how details are calculated, any questions you have about the tool, do feel free to reach out to us, and we're happy to answer your questions and provide you with instructions on how to use it. So now let's talk about some of the changes to the lighting controls requirements. We don't have enough time to cover all of the changes today, so we'll focus on a few of the highlights. One area where we've seen an expansion over the past couple of code cycles is with regards to occupant sensor controls. In the 2018 WSEC, several new spaces have been added to the list of spaces where the lighting is required to be controlled by occupant sensors. So this list here are all of the spaces that are required to have occupant sensor controls, and the ones highlighted in orange are those that are new. So it's now required in open plan office areas, in enclosed fire-rated stairways, service corridors, and in covered parking areas. Also note that there was a adjustment to the for warehouses, where it has been clarified now that it's only required in warehouse storage areas. Exceptions to this requirement include corridors in manufacturing facilities, and general lighting and task lighting in shop and laboratory classrooms. These spaces are exempt from the occupant sensor control requirement due to safety concerns. In addition, digital timer switch controls may be provided in lieu of occupant sensor controls in very small spaces that are less than 300 square feet. Now let's go through some of the occupant sensor control requirements for specific space types. For warehouses, storage areas, service corridors, and enclosed fire-rated stairways, vacancy controls are required to automatically reduce the lighting power by not less than 50% within 20 minutes of the occupants leaving the area, and they're required to restore the lighting to full power when the occupants re-enter. Aisleways and corridors, they shall be controlled separately, and the lighting in these areas shall be turned off when the building is vacant. And also note that these requirements do not supersede the egress lighting requirements in section 1009 of the IBC, particularly for stairways. Now, this is an interesting addition to the provision. Vacancy controls are now required in open plan office areas. Here's what the code states this should look like. They are required to control zones that do not exceed 600 square feet, and each zone shall be controlled separately. They shall automatically reduce the lighting power by not less than 80% within 20 minutes of the occupants leaving the zone. The lighting shall also be turned off when all of the zones within the open office plan area are vacant. So if you have a single person in their space, if they leave, the control shall reduce it down to 80%. And then when the entire area has been vacated, then all of the lights are required to turn off. Note that occupancy controls, they do supersede the daylight sensing controls. What this means is that when a vacancy sensor has triggered the lighting in the space to be reduced or turned off, the daylight sensor should be deactivated until the space is occupied again. This makes sense, although we do receive tech support questions about how these two lighting control requirements are to be integrated. For covered parking areas, the control zones shall not exceed 3,600 square feet, and each zone shall be controlled separately. The controls shall automatically reduce the lighting power by not less than 30% within 20 minutes of no vehicles or pedestrian activity being detected within that zone. If time switch controls are not installed, then the lighting shall be turned off by the occupancy sensing controls when all of the zones within the covered parking area have been vacated. Light reduction controls are not required for lighting within the entry ramp. This is also referred to as the daylight transition zone. Lighting is needed within this area to help the driver's eyes adjust to the abrupt change in brightness from the outdoors to the parking garage. Occupancy sensor controls are also not needed in parking garages served by very low wattage lighting, defined as less than 0.07 watts per square foot. Within the charging statement of the automatic lighting control section of the code, there is an alternative compliance path defined for spaces served by Luminaire level lighting controls. So the project can either comply with all applicable daylight sensing, occupancy sensing, light reduction, and automatic shutoff control requirements, or it can comply with the requirements for Luminaire level lighting controls. LLLC, Luminaire level lighting controls, is defined in the Washington State Energy Code as a lighting system consisting of one or more luminaires where each luminaire has embedded lighting control logic, occupancy and ambient light sensors, and local override switching capability. It also is required that each luminaire shall also have wireless networking capability to detect and share information with other luminaires to adjust to occupancy and/or daylight within that space. So Luminaire level lighting controls enable the following features. They provide luminaire and device addressability, which is the ability to individually address each unique system device independent of electrical circuiting. They support networking of luminaires and devices so that each addressed fixture, switch, or sensor is capable of individually communicating digital data between these devices in the room or space. They include occupancy and daylight sensing controls and automatic light level continuous dimming, which is progressive, gradual light level changes perceived as smooth adjustment as opposed to step dimming. They also support flexible zoning so that luminaires may be configured to form unique, reassignable control zones. Here's a comparison of legacy lighting control and Luminaire level lighting controls. Instead of installing and wiring a bunch of separate components, Luminaire level lighting controls can speed up installation, can shorten construction schedules, and it can reduce errors in the field. Here's an example of a code-required control zones within an office space. With Luminaire level lighting controls, additional zoning and layering of control schemes can improve energy savings and help tailor specific lighting needs by task, area, or even by personal preference. Future changes to lighting that would normally require pulling wire and balancing circuits are simplified by simple reprogrammable individual luminaire assignment. So in summary, Luminaire level lighting controls provide multiple benefits in a variety of ways. Sensors and control programming are integrated into the fixtures for straightforward setup that simplifies installation. Flexible controls reduce the cost of space reconfiguration. The ability to adjust each individual fixture can improve occupant comfort and productivity. Studies have shown that people perform better when they have more control over their personal environment. Lighting quality is improved by adjusting light levels to the preferred level based on the surrounding light sources, including daylight. Demonstration projects have reported from 25 to as high as 75% energy savings compared to standard lighting controls, and it offers reduced maintenance costs. In addition, LLLC supports integration with other building lighting systems. We would like to thank Better Bricks for sharing their helpful information about Luminaire level lighting controls. They have a lot of excellent information about this technology on their website, so if you're interested, we recommend visiting their site. We will also be posting various Better Bricks resources on our WSEC commercial website. There is an additional efficiency package credit for enhanced lighting controls. In a nutshell, a project may be eligible for this credit if each luminaire is individually addressed and is controlled by a digital control system. It is required to have occupancy sensors, daylight responsive controls, scheduling, and illumination levels of individual or groups of luminaires that can then be reconfigured through the control system. It states that no more than 8 luminaires may be controlled by a single daylight responsive control device. And the luminaires are required to be configured for continuous dimming. The control system needs to be capable of load shedding. And then specifically for open and enclosed offices, overhead general lighting needs to be configured to be individually addressed by the occupants. So now recall that occupant sensor controls are now required in open office areas. The capability for the occupant to adjust the lighting in their portion of an open office area is yet another expansion of lighting control within this space type. So now let's talk about a few changes to the electrical requirements in the Energy Code. The occupancy sensor control requirements for lighting are part of a trend within the Energy Code to address unnecessary energy usage by controlling all systems serving a space based on occupancy. The controlled receptacle provision is a part of this trend. Controlled receptacle provision was added under the 2015 WSEC as a first step towards reducing energy consumption from plug loads. These controls are required in enclosed offices, open plan office areas, conference rooms, print and copy rooms, break rooms, classrooms, and within modular partition or workstations, so those cubicles that can be reconfigured and moved around within the space. The general requirements under this provision, they haven't changed. They require that 50% of the receptacles within the space needs to be controlled receptacles. And a controlled receptacle has to be located within 72 inches of an uncontrolled receptacle. And then the two different types of receptacles, they need to be clearly visibly differentiated. And then there are two compliance options for how the vacancy controls can be handled. So they can be set up so they automatically shut off the receptacles within 20 minutes of occupants leaving the area, or they can be controlled via a timer switch, which turns the power off at program times. And if that is the approach taken, then the programmability of that system needs to be 7-day standard programmability. And then the maximum control zone area for controlled receptacles is 5,000 square feet. So there are a couple of new requirements in the 2018 WSEC for controlled receptacles. They are now included in the scope of commissioning. So our interpretation of the new language is that if commissioning is required for the lighting controls in a space, which is triggered by the total lighting power in the building, and that threshold is 20 kW of lighting power, or 10 kW of lighting power that is controlled by automatic lighting controls. If that is the case, that trigger then also triggers that controlled receptacles are also required to be commissioned. So commissioning, as far as we can tell with the new language, is connected to whether lighting controls are required to be commissioned. There is also language about controlled receptacles in Chapter 5 for existing building alterations. It now states that controlled receptacles are required where the receptacles are added or replaced. There are, however, several exceptions to this requirement. If the alteration project impacts an area less than 5,000 square feet, then controlled receptacles are not required. Also, if the project involves existing modular workstations or cubicles that are reconfigured or relocated within the same area, then controlled receptacles would not be required in that case as well. And then also any new or altered receptacles that are eligible for any of the exceptions under Section C410, which is the controlled receptacle section for new construction. The City of Seattle has put together several helpful resource guides about controlled receptacles for building designers, building operators, and occupants. These resources are available under the Code section of Seattle's Department of Construction and Inspection website. So we recommend, if you're looking for more information about this, we suggest checking out those very helpful resources. So, last but not least, let's talk about a new requirement in the 2018 WSEC. There is a new chapter in the code called Solar Readiness. The purpose of this new requirement is to encourage more widespread utilization of on-site renewable energy. This provision requires accommodations in new buildings that will support a future solar array. We have had conversations with various industry professionals, particularly electrical engineers, about what is required to integrate a solar system into a building. They noted that if accommodations are not incorporated when the building is first constructed, it will most likely be more expensive, and in many cases much more expensive, to incorporate a solar system into the building down the road. So this new requirement in the code sets up all that is necessary so that on-site renewable energy can be more readily incorporated into a building. What is unique about this new energy code requirement is that it requires a fair amount of collaboration between multiple disciplines to cover all the necessary elements. So for the architect, they are required to provide a designated area that's free of obstructions that will accommodate a future solar array. The structural engineer needs to design the structure of the roof to accommodate future loading of the solar array. The electrical engineer or contractor, they need to design an electrical system that accommodates the interconnection that is necessary for a future solar system. And this section also highlights that all applicable IFC requirements are also apply, which is a given. So the question that everyone always asks when a new code requirement is introduced is, when is this new provision required? Like, do I have to do this? So this is new for all of us, so we're figuring it out along with everyone else. But our interpretation is that it's required for all non-residential new construction buildings that are 20 stories or less. There is an exception for buildings where the roof area is anticipated to be substantially shaded. To meet this exception, the designer is required to demonstrate that less than 75% of the roof is unshaded using one of the three calculation methods that are defined in this section. And it mentions incident solar radiation study per meteorological year data, or an annual sunlight exposure expressed in the cumulative hours per year using TMY data, or you can do a shadow study. So let's go through the various requirements in this provision by discipline. So the architect is responsible for the following details. They need to show the solar zone area. It needs to be designated on the architectural drawings. And the minimum required solar zone area is either 40% of the total roof area, and this would be less any areas for skylights and any occupied roof decks. Or it can be 20% of the electrical service size. And the required solar zone area based on electrical service size is based on 10 peak watts of photovoltaic per square foot. Now, there is an impracticality exception, and I'll just read that exception so that everybody's clear what it says. It says, subject to the approval of the code official, buildings with extensive rooftop equipment that would make full compliance with this section impractical shall be permitted to reduce the size of the solar zone required to the maximum practicable area. So the gist of this is that this exception is not so that a project doesn't have to comply with this provision at all. All it's saying is that if there are obstacles to meeting the required percentage of designated roof area, that the designer can coordinate with the jurisdiction and figure out what would be a practical area that could be required to accommodate a future solar system. So do note that. Also, the actual area that's designated for the solar array, it may be located on the roof of the building, or it can be on another structure elsewhere on the site. And then it cannot be located on a roof sloped greater than 2 to 12 that faces within 45 degrees of true north. And so that is actually a detail, we'll be looking into that a little bit more. If that is the case for your building, if that's the slope of your roof, and that is all you have available, then that would be something that you might be able to coordinate with your jurisdiction to find out what would be feasible for that particular site. In addition, the architect needs to make sure that the in their designation in their plans, all the different areas that they are planning to set aside for the solar array. And the solar array does not have to be contiguous. So if you've got mechanical areas on the roof, and so you're not able to designate a one single area that covers 40%, then you can break it up into multiple different sections. A designated area needs to be set back from any existing or new object on the building or the site that would shade the array. So this would include things like parapets, chimneys, antennas, signage, any kind of rooftop equipment, and even trees and either on site or on the roof, and as well as roof plantings. The area shall be free of obstructions, and we're referring to things like pipes, vents, ducts, HVAC equipment. However, the plan could be that the array may be installed above these obstructions. However, if that's the case, what the code says is that if the designated area is over these obstructions, then the structure that would be necessary to support the array does need to be included in the original first construction. So that would not be something that could be added later on. And then the area does need to account for any emergency smoke ventilation elements of the fire code. And the architect also needs to designate areas for access pathways from a roof access point to the arrays and the inverters so that they can be maintained. So for the structural engineer, they are required to include loading information for the solar array and any components on their structural drawings. So they need to assume a dead load for the solar array of at least 4 pounds per square foot, and that is in addition to other required live and dead loads that would be on that roof area. And then they need to include a designated location for the future inverters, either within or adjacent to the solar zone. And the minimum for that is 2 square feet per 1,000 square feet of solar zone area. And the dead load that needs to be included in their calculations for those inverters is 175 pounds per square foot. And then if photovoltaics are actually included in the project, so this is not just future accommodation, but it's going to be part of that scope of work, then of course the structural engineer would utilize the actual loads and not these minimums. Now, the electrical engineer or contractor, they are also required to include accommodations in their design for a future solar array in their electrical drawings. So in their documents, they need to include the solar zone boundaries and the access pathways. So the same information that would be found in the architectural drawings. They need to designate a location for future inverters and metering equipment on the roof and within the electrical rooms. And they shall also include information in their one-line diagrams for future connection to the solar array. And this really does need to be built into the switchboard during initial construction for the reasons we talked about earlier. And then they also need to designate future wiring pathways from the switchboards to the inverter and then to the future solar array areas. So under additional efficiency package credits, there is a credit package for renewable energy. So our interpretation is that if a project complies with all of the solar readiness requirements and includes installation of the solar array in their project, then this fulfills the solar readiness requirement and the project may claim the renewable energy credit, provided the system capacity meets the minimum capacity defined in Table C 406.5, which is that's the provision for the renewable energy credit. Okay, so that concludes our training today about the key changes in the lighting and electrical provisions of the 2018 WSEC. Thanks so much for listening. We received several questions via chat. In this time remaining, we'll go through a few of your questions and share our initial feedback. After the webinar, we'll put together a list of all the participant questions posted along with responses from our Energy Code technical team. We'll send out this Q&A list as a supporting resource via email to everyone who is registered, as well as we do have a new webpage on the WSEC website. It's called On Demand Training, and so that's where you'll find the prior webinars that we've put on. We do have them posted now for on-demand viewing, and we will be including in the same area on that web page additional resources on the topics that were covered in that webinar, as well as the Q&A list that we put together from those webinars that will be posted along with the webinar itself as well. So this webinar is being recorded and will be posted on our new WSEC website along with the completed Q&A lists. So we're going to transition over to the Q&A session, so give us a couple minutes while we do the switch. Thank you.